All right, so we now know how to describe our center numerically, but we need to talk about how to measure, or talk about our measures of spread, how we do that numerically. Here's an example. This is not the exact numbers that were given, but this is an example of a question I asked back when I was much thinner and when I was teaching at SDSU. So I had a bunch of college freshmen, 18-year-olds, fresh out of high school in my Stat 119 class, and I asked them to guess my weight. I had them had 3x5 note cards, and I said, guess my weight, write what your guess is on there, and then just write an M for male or an F for female. And this is essentially what I got back. I made a back-to-back stem plot. So this back-to-back stem plot, this side was the female guesses, this side was the male guesses. Oops, male. And this is basically what I saw, is that both groups were right on in terms of their guess at how much I weighed. I think I weighed like 117 pounds at that time. I was running a bunch and about to get married, and I don't know. So I was grossly underweight. But anyways, I was 117 pounds, and both groups were pretty much right on the mark in terms of knowing how much I weighed. But what I noticed was the women were way more accurate. 18-year-old college freshmen had a much better understanding of, freshmen who are women, had a much better understanding of how much a lady weighed, whereas 18-year-old boys, I'll call them boys, did not know how much a woman weighed. I had guesses all over the board. People who thought I weighed less than 100 pounds, people who thought I weighed more than 150. It was bananas as I was looking at these guesses. And I don't think they were jokes. I just think literally the only frame of reference was how much they weighed. And so they didn't really know how to compare a female's weight to a male's weight. So this is why we care about spread. Something that might have similar centers might have very different spreads, and that is important to us because it talks a lot about the shape of our distribution. Other ways to refer to spread, just so I can use all of these to say the same thing: variability, how much variation there is in our data; dispersion, how dispersed our data is; and then scatter, so how scattered our data is. These are almost always referred to as in how far away from the center are things. So we have 4 or 5, I don't remember, a ton of different measurements for the spread of the distribution. Some are a little sillier, some we definitely need to know. So the range we've already seen. The range is just, if you want a calculation, max minus min. I will never ask you to find the range in this class. It is a middle school level question, and the range is stupid. I'm sorry, it's stupid. Think about that one we had before, with a min of 10 and a max of 80. Well, that's a range of 70. What does that tell me? Nothing. Nothing that not knowing the min and max would know. So I don't love the range. Really, the best time you'd use it is in that histogram. Instead, we might want to talk about the IQR, the interquartile range. The interquartile range looks only at the range of the middle 50% of your data. So now it's saying, oh, all the data ranges, like the middle 50%, a typical student, right? The middle 50% of my students in my stats class scored between this and this. Here's that spread. That's a lot more interesting and a lot more useful. So in order to find an IQR, your calculation goes like this. First, we need our data from smallest to largest because we're finding medians, right? We're finding middles. And then we got to find the actual median. The reason we want to find the median is because then we can figure out what our two halves are. So as you can see with an odd number, the method that the calculator uses, this is the calculator's method, is to exclude that when you look at your halves. So your half would not include, your half would not include the 15, right? This would be the lower half and this would be the upper half. That being said, this is one method. This is the Tukey method for finding Q1 and Q3, for finding quartiles. Other methods, there's one called the Hinge method, and in the Hinge method, it actually includes the 15 in both halves. And it makes a big difference in terms of what your values are. So just want to throw that out. The only reason that matters is that Hinge method, including in both sides, is what the StatCrunch does, so that software that we use. So this is one time where if you do some basic data set, you will get different values for something as simple as IQR between the StatCrunch and calculator. This is our first lesson in how statistics is very subjective, and there are a lot of different ways to do problems. Even something as basic as finding the middle 50% we're going to have disagreements on depending on who's doing it and what technology is being used. For an even number, this is much more straightforward. You just divide your data in half. All right. Once you have your data in half, then you can find your Q1 and Q3. Q1 is the median of your lower half. So if you look at only the lower half of your data, you want to figure out where the middle is. In this case, the middle would fall right between 10 and 11 at 10.5. For the other set, it would fall right between 19 and 20, which we would average to 19.5. Whereas with the even data set, with 3 on each side, it's much easier to see the median and just go ahead and grab it from both halves. And then your IQR is just that difference. So the IQR for that second data set would just be 20 minus 11, which is 9. Actually ends up being the exact same for both data sets. And that is what brings in a really good point. Look at that IQR. It didn't matter if I had an 80 in there or not in there. My IQR is 9 regardless for either of these data sets, the one that has a very tight spread or the one that has a pretty tight spread with that one crazy number of 80. I can even make this thing 800 and my IQR is still going to be 9. So imagine, since the IQR is using medians, it is just like the median itself, very good at excluding and ignoring those crazy outliers. So that's a preview of what's coming next. All right, so we got 2 examples of finding the IQR. I'm going to go ahead and break these into their own videos. So feel free to try them on your own. Scroll to the end of the video and see if you got it right, or walk it through it with me in the video if you want.